So today is the last day of this 21 days masterclass on embedded systems Arduino. So today we are going to learn about interfacing capacitive soil moisture sensor with Arduino. So keeping a house plant alive can be a tough job, right? And often it's just about remembering to water it. Fortunately, soil moisture sensors can help us remember to water out plants and help them live longer. However, the majority of inexpensive soil moisture sensors are resistive style, where there is two prongs and the sensor measure the water content in the soil based on the conductivity between them. They work fine initially, but over time they start to rust. Even if they are gold plated, this rusting messes with the reading, so you have to keep adjusting your code to get it right. Also, they don't work that well in loose soil. So luckily there is a better option, which is capacitive soil moisture sensor. These sensors operate based on capacitive measurement, which offers significant advantages over resistive measurement. So these sensors have only one drop, no exposed metal to rust, and don't harm your plants by introducing electricity in the soil. In this session, you will learn how to effectively use capacitive soil moisture sensor with Arduino. By the end of this session, you will have the knowledge and skills to keep your plant thriving without having to worry about under or over water. So let's get started. See, this is the hardware overview. So capacitive soil moisture sensors are quite amazing. Just stick them into the ground and they output an analog signal that is proportional to how wet the soil is. So these sensor makes use of a 555 timer IC and operate by measuring how quickly a capacitor charges through a resistor. But in these sensors, the capacitor is not a literal component, but it's formed by two PCB traces that are near one another. So their capacitance and therefore their charging rate changes in response to how much water is around them. So the sensor includes an onboard 3.3 volt voltage regulator, making it suitable for 3.3 volt and 5 volt microcontrollers. So plus it consumes less than 5 milliampere of current only. So note that this sensor can only provide a qualitative measurement of soil moisture. As the soil gets wetter, the output voltage decreases. As it gets drier, the output value increases. So when powered at 5 volt, the output ranges from about like 1.5 volt to 3 volt. I mean from wet soil, 1.5 volt is for wet soil and 3 volt is for dry soil. So however, the final output value is affected by probe insertion, the insertion depth and how tight the soil packed around it is. Okay. Now see this. This is the technical specifications of this capacitive soil moisture sensor. The operating voltage is like 3.3 to 5 volt and operating current is about less than 5 milliampere and output voltage at 5 volt is 1.5 volt to 3 volt and sensor probe, which is this is a size and cable length is 20 centimeter. Okay, so now see this. How does a capacitive soil moisture sensor work? So, to understand how a capacitive soil moisture sensor works, you need to first understand the behavior of the capacitor in the RC circuit. So, in a simple RC circuit like this, when a positive voltage is applied to the input, the capacitor begins to charge through the resistor. As it does, the voltage across the capacitor changes. Over time, the capacitor voltage rises to equal input voltage. Here you can see a graph plotting voltage against time for the charging capacitor. I will show you this, right? So see this graph. The time it takes for the capacitor to fully charge depends on the values of the resistor and the capacitor. If you keep the R constant and try two different capacitance values for C in the sense, you will observe that a capacitor with a larger capacitance requires more time to charge. Whereas a capacitor with a smaller capacitance requires less time to charge. So see, now coming back to our sensor, the capacitor C on the sensor board is not a literal component, but simply two copper traces that act like a capacitor. This effect known as parasitic capacitance. Happens often in like circuits and is usually negligible. So, however, by deliberately making the two copper traces larger, we can use this effect for our advantage. So, microcontroller like see, the capacitance of this parasitic capacitor is determined by the shape of the traces and the environment surrounding it, technically known as like dielectric constant. So, as the sensor is inserted into the soil, the environment around the capacitor changes depending on whether the soil becomes wetter or drier. So, this alters its capacitance and consequently affects its changing time. So, when the soil is dry, the capacitor has a smaller capacitance and therefore charges quickly. Conversely, when the soil is wet, the capacitor has a larger capacitance and therefore charges up more slowly. To better understand how this is implemented in the sensor, let's examine this circuit diagram. Okay, so the sensor uses a 555 configured as an astable oscillator. So the square wave generates by the 555 are fed into the RC integrator, of which the capacitor is formed by the soil probe. So the signal from the integrator is more of a triangular wave, which is fed into the rectifier and a smoothing capacitor to produce a DC output. So this output is proportional to the moisture content of the soil. So if the soil is dry, the capacitor charges quickly, resulting in a greater amplitude of the triangular wave and subsequently producing a higher output voltage. So conversely, when the soil is wet, the capacitor charges more slowly, resulting in a smaller amplitude of the triangular wave, which in turn generates a lower output voltage. So see this now. Capacitive soil moisture sensor pin now. The capacitive soil moisture sensor features a 3-pin, which type of like JST PH 2.0 type connector. One end of the provided cable plugs into the connector, while the other end is the standard DuPont style 3-pin female connector. The cable is color coded, so you can easily identify which wire is which. I mean, black represents ground, red represents VCC, and yellow represents output pin. So coming to the VCC pin, VCC is the power supply pin. It is recommended that the sensor be powered from, you can give like 3.3 volt to 5 volt. So please keep in mind that analog output will vary depending on the voltage supply to the sensor. And there is the ground pin, which we have connected to the ground pin into the Arduino's UNO's ground. An output pin, it gives an analog voltage output that is proportional to the amount of moisture in the soil. So the output can be read using an analog input on your microcontroller. As the moisture level increases, the output voltage decreases and vice versa. See, it is not possible to determine the actual percentage of moisture in the soil directly from the measurements taken. However, it is relatively easy to define basic ranges for what is considered like too dry, too wet, and just right like that. See, when the soil is dry enough that the plant needs watering. When the soil has been watered to its ideal moisture level for the plant. When the soil has been heavily watered and is too wet, which is not ideal for the plant. This is what we are going to find out. So for that, let us write a program to just get the threshold value. Okay. So let me move to the Arduino IDE. Here I am going to just a simple program. I am going to define as A naught, and then inside void setup we can go for serial dot begin 9600, and inside void loop I'm going to create a variable called value, this type of integer, and using analog read function, instead I'm going to pass sensor pin, and then I'm going to print it on the serial monitor. Okay, serial print, I'm going to print like analog output Instead we need to print that value, right? And then let's edit with a delay of 1 second. So let me verify this first. Our program is error free. So now let's move to the hardware part. So see, here we have Arduino Uno and this capacitive soil moisture sensor. I want to say something which is, see, when using this sensor, keep in mind the following things, okay? So I want to tell you that it's recommended that the probe should not be placed on the depth which crosses the limit line of the sensor. So this is the limit, you can see here, right? So this is the line, this is the limit, and the components on this board are not waterproof. So make sure that they don't come in contact with water or splashes. For additional protection, consider using a piece of wide heat shrink around the upper section of the board, right? Note that the edges of the PCB could absorb moisture over time. So shortening the lifespan of the sensor. To increase durability, consider applying like a protective coating, like such as a clear exposé, which won't affect the sensor in performance, okay? So now let's move to the connection. Yes, we need to connect these 3 things with this Arduino Uno. So black is for ground. And red is for 5 volt. You can give 5 volt or 3.3 volt. It's your wish. And yellow is for analog pin. And I'm going to connect this thing. First, I'm going to place it outside. Then we can go for this thing. See. So, here we are going to uploading our code. So, before uploading it, I want to tell you something. So, here we should note few things, which is we need to take the reading of in open air and dry soil that needs watering. In open air, what it will provide you the value. During the dry soil, when it detects that soil is dry, what value it will provide. And when you just watering the plant, after you place your probe inside the pot in the sense, what value it gives. And then when you place this probe in just a cup of water, so what it will provide you. So you have to notice these 4 readings. One in open air, another one is dry soil that needs watering. Third one is soil that just been watered. Fourth one is in cup of water. I have already take the reading of these 4 things. I will show you here. So once you have the readings, you can use them as a threshold to trigger an action. Okay. So now I am going to upload this code. So see, it's uploading. Okay. So let me open this. In here, it will print like 529, 526, 514, 503, 506. It will give the variation. Okay. So now I am going to place it inside this. So now it will providing you the values like 400 something, 500 something. I'm going to place it inside this. See, it will provide you like 400 something like. So another 2 thing, I have already poured some water into it. If you pour some water into the pot in the sense, it will give you another value, which means the soil is in wet state. And you have to also note down another one reading, which is take a cup of water and place the probe inside the water and take the reading, what it will provide you. Okay, so these are the 4 things you have to notice first. So this is how you can get the values. Now we can go to the next topic. This is the right time to switch your masterclass into certified internship. So in this 1 month internship, you will get 90 days access to complete records. You will get internship certificate and you can download all the presentations. You will get 8+ project source code, and for every week there is a mastermind session. You can clear your queries and doubts with your mentor, and there's a particular group for internship members, and you will get access to Pantech community and as well as career guidance sessions. So in this internship we have include some projects. Let's see what it is. Soil moisture control, smart street light monitoring, water quality monitoring, smart parking using Arduino, health monitoring, smart circuit breaker using Arduino, ATM security using Arduino, vehicle speed controller, and surveillance systems using Arduino. So now see, now let's estimate the level of soil moisture using the threshold value. Okay, I have already noticed all my values here. So now let me rewrite it. First, I am going to define for wet soil. I'm going to define like 277. I mean, this is the maximum value we consider soil as wet. Now for dry soil, this is I'm going to give like 380. So this is the minimum value we consider soil dry. And now sensor pin A0, and we can go for void setup. So inside there is nothing, just serial dot begin. That's it. Now inside void loop, first what we need to do, we need to read the sensor pin and store it in a variable, right? So int, I'm going to create a variable like moisture using analog read. Inside I'm going to pass like sensor pin, and then I'm going to print it first. So serial print analog value Now I'm going to make a condition. So first condition is if moisture is lesser than wet soil, in the sense inside I'm going to print like status, which is soil is too wet. This is what I am going to print. So now another condition, which is else if condition. So here moisture is greater than or equal to wet soil and moisture is lesser than dry soil, in the sense inside I am going to print like status, which is soil moisture is perfect. Now else condition. Here I want to print like soil is too dry and it's time to water. This is what I am going to print. And after these all condition, I am going to leave a blank line. Okay, serial println, and let's end it with a delay of 1 second. So let me verify this. Okay. So now let's go to the hardware part. So the same connection, let me upload it and see what it will print like. Okay, I'm placing the probe inside the soil. The soil is too dry, time to water, which means the soil doesn't contain the necessary moisture. It doesn't have the needed water. So that's why it printed like a soil is too dry, it's time to water, which means we have to pour some water into it. Let me take outside what it will print. Same, soil is too dry, time to water. Let me place it somewhere else. Let's find out if it detects some moisture or not. No. See, it's print like only one line, soil moisture is perfect, which means that particular place only have that moisture level. Otherwise, all the things are actually too dry. I pour some water in the morning. That's why it print like this. Okay. So this one have the moisture is perfect. So here it will have the needed moisture, I think. Okay. So this is how you can find your moisture level of your soil. So this is our output. If you want to, if you pour some water into it and you will measure in this, you will maybe get like you have the perfect moisture level. So this is our output. And this 1 month internship is just 699. Use this link to make your payment. And also there is 3-month internship on embedded system. The lines up are Arduino programming, Raspberry Pi programming, Internet of Things and PCB designing. This is for 1299. And in this 3-month internship you will get 360 days access to complete records and 3 certificates. You can download all the presentations. You will get 18 plus project source codes and every week you will have mastermind session. There is a particular group for internship members and you will get access to Pantech community as well as career guidance session. So this 3-month internship is for 1299. Use this link to make your payment. If you have any queries, you can contact this number. The coordinator will guide you.